Hello College Math students, here's a familiar one, Pythagoras' Theorem. Now, Pythagoras' Theorem is something that I'm sure you've been exposed to in the past in maths classes. However, if you can't remember anything about it or you haven't ever seen it before, don't worry, I'll be going through it right from the beginning. It relates to right-angle triangles, and the rule is that if you take this side and square it, and take this side and square it, then that will be equal to this side squared. So we use this to find the unknown side of right-angle triangles, like these ones. So here on the very left, we're trying to find this side here. I'll just call it x. Here, there's no number on this side, so we're trying to find that one. With these ones here, we're trying to find this side, and here we want this side. So if there's no number next to the side, or there's, say, a letter x, that's the side they want you to find. Now, one part of a right-angle triangle is the hypotenuse. The hypotenuse side of a right-angle triangle is the longest side. So see how here, actually it was red, wasn't it? I'll just change to red. So here the hypotenuse side is this red side, the longest side of the triangle. So I might change my colour coding here a little bit. Make these ones, so this is, say, the hypotenuse, finding the longest side of the triangle. So in these two we're finding the hypotenuse, the longest side of the triangle, but in these ones, I'll change these to blue like they were on the other page. Here, there's the hypotenuse, that longest side there, the 15 metres. We're trying to find one of the shorter sides. And here in the one on the right, the hypotenuse is 8.7 metres. So we're trying to find one of the shorter sides here. So these two on the left will be done a little bit differently to the ones on the right. Now, what we know is that x squared will be equal to 5 squared plus 12 squared. But of course we want to know what x is equal to, so we need to take this square over and make it the opposite, which is square root. So x equals the square root of 5 squared plus 12 squared. Okay, tap that into the calculator. And we get 13 centimetres. Okay, now you might want to pause the video at this stage and try the next example. It works really the same way. Then I'll have a go at it. Okay, so this is what we do. Now I'm going to go straight to the square root. X is the square root of 7.2 squared plus 5.3 squared. Okay, so if we're finding the hypotenuse, we always have a plus in between the two numbers. Okay, so for this one, we get 8.9. Just going to one decimal place. Right, now in these examples over this side, similar way that this works, except when we're finding one of the shorter sides, we put a minus between the numbers rather than a plus. So just remember, if it's the longest side, hypotenuse, it's the plus. If it's one of the shorter sides, we put a minus in between the two numbers. It's really important, as you may discover, to have the biggest number first. So we wouldn't do, for instance, 12 squared take 15 squared. That won't work. That's not the right way to do it. We need to have the 15 first. In this case, the answer is 9 meters. Okay, you could pause the video now and try this next one. Okay, I'll have a go at it. X equals the square root of, okay, the biggest number first, 8.7 squared. Take the smallest number squared, and that gives us 8.1 centimetres. It says 8.09 ... but that rounds to one decimal place, 8.1 centimetres. So the lesson here is using Pythagoras theorem. If you're finding the longest side, the hypotenuse, we have a plus in between the two numbers. If you're finding one of the shorter sides, we have a minus in between the two numbers.